Hello, everyone, and welcome to our webinar today. My name is Dan Klimke. I'm the Director of Product Marketing at NetAlly, and I'm happy to co-present today our webinar on the Essentials of Packet Analysis, Part 1. So let's dig into it. But before we do, just want to make a special note, special announcement that today NetAlly is announcing a new capability in our product line. That's the ability to generate network maps in LinkLive from discovery data gathered by the EtherScope NXG or the LinkRunner 10G with Ally Care support. So we'll be taking a look at LinkLive shortly, but this is a really cool new capability, the fact that we can take our discovery data, pass that up to LinkLive, and then generate network topology maps. So in addition to being able to do your network analysis, Wi-Fi analysis, wired Ethernet analysis, the auto test, and the air mapper site survey capability that we announced earlier this year. Now you can actually generate network maps with the EtherScope. So improving and increasing the capability and value for our customers who own EtherScope. So if you want to take a look at that, go to that URL up above, netally.com/network-mapping, and you can take a look and learn a little bit more about that. So big announcement. Also, I want to make sure that everyone is aware that there's a part 2 for this class. This is just an overview today, but on Wednesday the 18th, Chris will be delivering a class going deeper with Wireshark, part 2. We'll actually also be sharing a trace file that you can actually follow along in that session to go through some of the tips and tricks about how to do those certain things. And with that, I want to introduce Chris Greer. Hi, Chris.
Well, hello, Dan. Great to be here with you.
Good to hear you. Chris's email address is there, and feel free to contact him. Chris has been, Chris is an old former coworker of ours. He worked with us back in the Fluke Networks days, and then went to work along with Mike Pinocchi at Network Protocol Specialists as a trainer and consultant, and now has his own company, Packet Pioneer, where he does packet analysis consulting. So in as much as Chris does a lot of educational efforts on using Wireshark, in fact, he's got a YouTube channel, just go look him up, Chris Greer. That's a picture of what his channel banner looks like. He also does consulting work. So in as much as we want to use these sessions to enable your skills, if you've got a tough problem or don't have the time to solve it, feel free to contact Chris for doing some remote consulting for you. And there's also that link, bit.ly/virtual Wireshark, that'll take you to some Wireshark remote training. So Chris, great to have you back and working with you again.
Thanks, Dan.
So with that, I'm going to switch over and we're going to talk first about how you can use a tool like EtherScope to capture packets. So we're going to start out here looking at LinkLive. So LinkLive, if you don't know, is a cloud service that NetAlly offers. Basically serves as a repository for test results and files generated from the handheld tools, and also has some new capabilities like that network mapping. So for example, I've connected here to LinkLive and I'm looking at the EtherScopes that I have access to. I've selected one as an example, and I'm going to click this remote button, and we are going to connect to that EtherScope remotely. So this is a great example of one way that you can capture packets without actually having to be standing there holding the tool in front of you. So this EtherScope is actually in a test network in our Colorado Springs engineering office, and we've connected to it remotely through LinkLive. And so I'm just going to click here on the capture tool or the capture app. A couple of things that we can do in terms of configuration of capture. We can set a file size limit. We can set slicing. If you're only interested in capturing headers, and Chris, maybe you could touch on when might I only care about headers versus full packet analysis. EtherScope has both a Wi-Fi port that we can capture off of or a wired Ethernet port, and that is up to full line rate 10 gig without dropping any packets. Now keep in mind the EtherScope is a single port analyzer. If you take a look at EtherScope, the ports that we have on the top, there's a SFP plus slot for 10 gig on fiber, any type of fiber connectivity, plus a single RJ45 port. So in terms of packet access, what we do recommend is that our customers utilize of course, you can capture off of span or a tap or a packet aggregator. And our friends over at ProfiTap make some great tools for packet access. The ProfiTap Booster is a great example of a tool for getting in line with the packets and porting those packets that you're capturing out to the EtherScope. So once we've selected our capture port, we can also set up some filters. We can filter by MAC address, IP, VLAN, TCP or UDP port, and we can embed some logic in the packet capture. But we're just going to straight capture what we've got on the line. So I'm going to go over here to the capture window and click Start. And you get a nice little strip chart here of packets coming into the analyzer. So we can see just a packet count of packet type and overall size of that packet trace file. So since we're, well, just grab what we're grabbing here. And we're going to save this file to link live. So here's another handy thing. Not only can I remotely connect to the unit to do the capture, I can actually upload that trace file to link live. And let me just change the name of this file. And we're going to call that slow app load. Let's say we're trying to analyze a slow application issue. So I'm going to click save. And for Chris, as a comment, and this is going to save up to link live. So I'll click the save file. And let's take a look, Chris. If all works according to plan, there's that file. Slow app load is waiting for you to do your analysis. So I'm going to hand control of the webinar over to you and have you go grab that file. And let me, of course, I have to tell the webinar that you are the presenter.
Okay, then.
And let's see, here we go. All right, you should have the ball and be able to take off from here.
I just shared my screen. I just want to make sure you can see Link Live with Wireshark behind it. Is that what you see there?
I do.
Okay, look at us. Okay, well, I'll go ahead and pick it up from here. So something that we definitely want to demonstrate to you fine folks on the webinar is just how simple it is to do that packet capture from a remote spot. We know a lot of times you can't just run out into a physical location and grab some packets. So having a device out there that has that capture capability is really nice. Now, the second thing, Dan was able within a few clicks to be able to grab some traffic and then upload it to a shareable cloud space where as a collaborative effort, he and I can work on this together, or maybe Dan's in a location where he doesn't have access to his Wireshark environment and he kicks that out to me because I'm in front of mine. Whatever the case may be, we have the ability to collaborate quickly and look at a trace file and to get to the root of our problem. So
hey,
here
Chris,
I'm,
sorry for interrupting, but before you go further, I just wanted to mention that people can use the question tab in the webinar controls to ask questions along the way. If it's something I can answer just along the way, I'll type in an answer for you. If not, we'll save that question to the end, or if it's really pertinent to what you're talking about, I may just interrupt and ask it for you at that point. So
that sounds good. All right, yeah, ask away. Everyone that's here, this is what we're here for, to really get some, just share some knowledge and find out what you need to know. So feel free to share those questions. Now, again, I'm on Link Live. with this browser, and I'm on to the same environment as Dan was that he saved this up to, so Studio 2020. Here I can see that trace file that he had saved out there, and I just come over there to slow app load, okay? And then I'm able to pull that down and open that up in Wireshark locally. Now, for those of you that came here for some Wireshark packet shredding, if you've ever been on one of my webinars, you know one of the things that I like to do is make sure that you have hands-on to where you can follow along with me. In this case, what we're going to have to do just for this environment, not for next week's, but for today, I'm just going to be walking you through this trace file and not specifically sharing this trace. But let me just tell you that if you have a local copy of Wireshark, if you just open up your local copy of Wireshark, and if you just go out to a couple of websites, just hit a few different places, stop capture, you will be able to follow along with all of the actions that I'm taking within Wireshark, even if you're not following me packet by packet, okay? So you'll still be able to get some hands-on if you follow along. Okay, so here I have the trace file open. Just a few things that I noticed right off the bat as an analyst, something that I just muscle memory, you get your eyes to start doing as you look around the environment. I come down here, or rather the trace file, sorry. I come down here to my lower left, I can see there's my name of the trace file. So that's the one I'm working on here. If I come over here to the number of packets that I'm working with, I just got just over 6,000 packets. Right now, since I don't have a display filter applied to this trace, right now I'm seeing all packets. So I don't have anything set just yet. Over here on profile, you and I are going to have a conversation about profile, and we're going to be talking a little bit about how to create one and why we would do so within Wireshark and how that can help our analysis. Again, moving around the screen, I can see my filter save buttons, and up here on top, I can see my 3-pane view within Wireshark that can help me do some packet digging. Now, you're going to notice that first of all, I have a setup here that might look a little bit different than yours. Here I've got my packet summary view, I've got my packet detail view, and over here, this is where I have my hexadecimal view. And these are all configurable views that I can change so that I can get more out of my analysis. Now, for me as a preference, one of the things I like to do is just keep my packet view or my hex view over here on the right. And the reason is that I find that when I have the 3-pane view where the top is summary, the middle is detail, and the bottom is hex, I find that there's usually a lot of white space over to the right. That's because in the detail view, a lot of times like this, for example, quick, this isn't spanning the entire length of the detail view, right? So if this view was on the bottom, the 3 would be stacked, but I would have some white space over there. So that's where I like to make use of that space and put my hex over there along with my clear text view. I'm going to show you how to do that in just a second, but just wanted to note that for you as you're looking at my setup. Now, with Wireshark, setup is a big deal. We want to make sure that we have Wireshark configured so that we can get the most out of our analysis. So the first thing I'm going to show you is setting up a profile. And the profile we're going to use today is going to be a DNS profile. Now, why DNS? Well, there's a few things that Dan mentioned when he did his capture, things that I was listening for as an analyst. Did you catch them? He threw us a couple of cues. He said that he was troubleshooting an issue with a slow application and even named it slow app load. So what does an application need in order to load? Well, if we go through the process, just starting down at the lower layers, the local device needs to ARP. It needs to be able to get the MAC address of its gateway or another device if it's local. It needs to establish a connection with whatever server is on the other end. It also needs to do a DNS lookup in many cases, right? Now, slow meant it worked, but there was just some delay. All right, so that word, just like it should just hone your attention. In slow app load, we're usually not looking for things like ICMP errors that are saying this thing can't connect at all. Or maybe we sent out a TCP SYN and then we sent it again and sent it again and we just never got there. Or maybe even, again, this is just assumptions, but things along the network path that would completely stop transmission, right? Because in those kinds of things, it wouldn't be a slow, it would be I call it a no. There's no connection whatsoever. But in this case, it did actually work. So some things that can contribute to that, again, DNS is going to be one that I just want to validate to make sure that that is healthy. Then after that, I can start to move into TCP if the app's using TCP, take a look at my handshakes, look at my round trip times, and so on. So what we're going to do for the next 2 sessions, the first one today, we're going to talk about the DNS facet of an application loading. And next week, we're going to talk about the TCP intricacies, the importance of understanding how TCP works to move that data from one point to another. All right, so DNS and TCP. So TCP, make sure you're here next week. DNS, let's get digging. Now, as soon as I say DNS with Wireshark, for me as an analyst, I go, okay, what kind of filters, what kind of things would be useful when I'm going to be focused on a DNS type of issue? I want to make sure that those things are like quick keys and things that I can quickly filter on or set within Wireshark, so I don't have to spend a lot of time digging down to my DNS. So to do this, first I'm going to have you come down to Profile. You're just going to hit right click. Now, what we're going to do is just say new and go ahead and follow along with me on your local copy of Wireshark because this will be useful to you. We're going to say new, and this brings up our Wireshark configuration profiles. Okay, now briefly, a profile is think of it as a set of settings. All right, if I go out to my car and on the side of the driver's seat, there's numbers 1, 2, and 3 for 3 different driver configurations. All right, my wife is 5'1", I'm 6'2". You can imagine that I have to move that seat back quite a bit, steering wheel changes, even mirrors, those kinds of things. Well, some cars have the ability, I can just hit number 1, and this thing just changes all of its settings for me. My wife comes out, look, she can hardly touch the pedals, right, when it's on my setting, so she clicks number 2, and boom, the seat comes up, and now she's set. In a similar kind of way, we come in and we just say, okay, what kind of protocol are we going to configure or analyze? What kind of issue are we looking into? I want to quickly get to settings that would be useful. That set of settings is called a profile. So what we're going to do is we're just going to say new profile. We can call this DNS. And then actually, you know what I'm going to do? I'm just going to call this DNS webinar because I actually already have a DNS profile in this system, but I'm just going to create one right along with you. I'm just going to hit OK. And now I'm in my DNS webinar profile. Now you notice that things changed for me. The font got a little bit smaller. The system changed my layout a little bit. And now I have the ability to go in there and do some configurations. So first, just for making things look a little easier for you guys, I'm going to come up here to my and enlarge the main window text button. So that'll let you see that a little closer. I'm just going to hit my button over here to the right. That resizes the packet list so everything fits nice and well within the columns. And for right now, I'm going to go ahead and change my screen layout so that instead of my 3-pane view, I go ahead and put this hex view up over here to the right. So I'm going to show you how to do that. If I'm on a Windows system, I can go to Edit, and I want to come down here to Preferences. If I'm on a Mac system, I go up to the top and I click Wireshark, and Preferences will be under Wireshark, not Edit. Just a subtle difference depending on your system. Okay, so Preferences, and I'm going to come in here to Columns, and while I'm here, I'm going to go ahead and add another time column. Now the default, I see I have a time column here, time format is specified. Now behind this, I can come over here to time, and I can see that by default, this is the running total of time. It'd be like if someone started a stopwatch on packet number 1, and that as each packet comes in, that timestamp will cause me to see at what point in my time did it come in. So to come in at 1 second, 2 seconds, 3 seconds, starting from 0. Now that's a default time column. That's something I can change up on the summary view in the back here. I can change that if I'd like to. Or for me, something I find that's very useful is it's nice to have one time column that's like a running total, a cumulative time. And right next to that, what I like to have is a delta time. And what delta time shows me is the amount of time between the packets. More technically, it's the time between the end of one packet to the end of the next one. So that shows me where time is being spent. That's very critical. we always want to have a delta time column. And again, why? Remember what Dan told us. Slow, intermittent, weird, something didn't seem to be operating as efficiently as it should. So you and I, like a hound dog, we're going to go in after time. And to help us to do that would be a delta time. So while I'm here on preferences, what I can do, go to columns, and I'm just going to say plus here. And I'm going to change the name to delta. And then my type, what this does is I'm manually setting what value do I want to show in this column. Now, remember what I told you, delta time. Let's go up to the D area, and here I can see delta time displayed. That's the one that I want to see. Now, important that you say displayed, because if I add a display filter here in Wireshark, I want the delta time to reflect the displayed packets. I don't want this to be true delta time from this packet to the one before it in the capture. I want this time to be this packet and the one before it that I see. So it could be that I have one packet and 100 packets were in the capture between this packet and the next one, but based on my filter, I only see those two. I want to see the delta time between those two, not between the captured packets. That's why we'll select delta time displayed. Now, just to make from a visibility standpoint, things a little easier on myself, I'm just going to take delta time displayed, drag this up, and I'm going to plunk it right there. See if that, there we go. So now we got time and we got delta right next to each other. So I want to be able to see those time columns. Next, while we're here in preferences, I'm just going to go to layout. Now, there's several different layouts that we can choose from. The standard default view is here. As a preference, this is the one that I like to choose. Now, just note to all of the listeners out there, if you've ever been on one of my webinars in the past about Wireshark, something that I'd like to make sure you know, it's your way or the highway. All right, if you like the stack view here, use it. But right now, we're in my profile, so it's my way, right? So this just helps me. However, but for you, if you have a larger monitor with a lot of real estate, or if you have one that's that's top to bottom view, sometimes these other views can be pretty useful. So I'm just going to select this one, and I'm going to say OK, and that gives me right away a bit more of a, for me, a little easier to view my information. I got my delta time column now. I've got my hex view over here with my ASCII characters, and then I can start to do some digging. Now again, all of that was saved in our profile. Anything that you change at this point, even if I come in here and I just drag this little line down here so I can see more of my packet summary view, that is now saved in this profile. So this is super useful for doing troubleshooting of different types of applications. All right, so that was the first thing that we were going to learn how to do. Let's go ahead and go on to the second thing. Now, something else that Dan had mentioned was, again, going back to what he had mentioned, rather, keeping our eye on the ball there, was slow. So I want to be sure that DNS is healthy for this system. Okay, so we're going to go ahead and come up here to display filter, and let's just take a look at the DNS that we have in the trace file. So simply, what do you think the DNS filter is in Wireshark? I know filtering can be a pain, but this one's easy. DNS, you guessed it, right? Or alternatively, we can be a bit more complex with it if we really want to, but this is going to be the simplest way to do it. Now, as we go forward and start to build filters, this is where Wireshark can help us out. If I put a filter in there and I have it correct, that filter bar is going to turn green. So thumbs up, I got it right. If I have part of a filter that isn't complete, or if Wireshark doesn't quite understand what I'm trying to do here, it's gonna give me a red box. So it's saying, hey, Chris, sorry, you missed something here. And here's some suggestions of what you may have meant. All right, so I'm gonna go ahead and hit DNS. We're just gonna hit enter. All right, so in this trace file, if I look down, muscle memory, down to the bottom under displayed, I see packets, displayed. I've got 106 DNS packets here in this trace file. All right, so now let's start to take a bit of a look on what the health of DNS is. Now here in this application, there were several different DNS queries. So just to show you some of the features that Wireshark uses to help this along, one that I'll point your attention to is over here on the left under the frame number. Now you notice I have my little arrows here, right? Super useful. This is pairing the DNS request and the DNS response together. It just so happens in this case that the request and the response were one right after the other. So right here, I can come over to Delta time, and I can see that .21, my client, went out to his DNS server, and the DNS server came back 24 milliseconds later. And if I take a look at my standard query response, I can select that response, and if I really want to, this is where I can start to do some digging. I can come down here into the DNS flags. This was no error. Things looked okay. This message is a response. I can take a look at the question that was asked. So what were we looking for? safebrowsing.google.com. And importantly, I want to come down here to answers. And what I would like to see, usually I see a couple of aliases there for Google, but I want to come down here to address. So this was the actual address that was returned for that name that I was looking up. I also can see that the question or the query, just a quick little side point as well. Under the query, I was doing a type A lookup. So that's going to be requesting a host address that's going to be an IPv4 address. If you see a quad A record that I'm looking for, that's when I'm looking for an IPv6 address. So right here, server came back. All right, here you go. Here's your address. This is a type A record, and you can just take off and start to do your TCP, or in this case, maybe this would be a quick protocol that would follow this, Google Quick. But super handy, right beneath this, come down here to time. I'm just gonna click on that for a moment. Now again, if you have a local trace file that you're working with, anything that has DNS or just generate some real quick, you're gonna see this too. Now Wireshark does us a solid here. It says, all right, DNS time. So anytime I select a field in detail and I come down here to the bottom, I can see what field is Wireshark referring to here. You see DNS.time right down there, DNS.time. So this is showing us Wireshark is saying that this response came back 24 milliseconds later. Awesome. Wireshark is timing that for me, and it does it for every single DNS request response that it recognizes. Now, you might think, okay, whatever, Chris, that's not a big deal because you got Delta time right up here, right? And really that should be the same. I should see Delta time and the DNS time when they're right next to each other. Usually those two numbers are going to be the same. However, it's not always nice and neat and cleanly filtered like it is for these nice cooking show demonstrations that we do. Sometimes I can have a trace file with millions of packets, and I want to go in there and I want to find the slow DNS responses. Well, guess what I'm going to filter for? DNS.time. In fact, in a DNS profile, DNS.time is such a useful thing that I want to see it for every DNS request and response. Okay, I don't want to have to go digging for it like you and I just did. I want to take this metric and I want to throw it upstairs into the packet summary view. Okay, so how do I do that? Well, I'm just going to right click and I'm going to come up here to apply as column. All right, now if you're on a Mac system, that's where you can just do a 2-finger tap and you should see the ability to do apply as column here as well. Take that, apply as column, and I'm just going to resize my columns a little bit. And here, what I see now, pull that in just a little bit. Now I took that time and now I threw that upstairs. So now, just with a glance, I can see my response times. Wireshark is measuring those for us. Now, something I forgot to mention, in Wireshark, anytime you see those hard brackets, right? You see these brackets around a detail. So for example, request in, or up here, label count, name length, these kinds of things. Those are Wireshark derived values. So this 24 milliseconds is not a part of the DNS actual protocol structure. The DNS protocol doesn't say this. Wireshark says it. So those are really nice things to keep an eye on while you're digging through your trace files. Look for those things that Wireshark helps you out with. Wireshark says, you know what, you're probably looking at the response time here. Let's go ahead and throw this upstairs. Now, super nice, DNS.time. Something I can do here, anytime I throw a column up here, right? That's something now that I can sort for. It's something I can filter for. So as we're building out our profile, we can start to see there's some filters we can start to build, right? For example, let's go ahead and sort this time. Now for me, when I'm doing DNS analysis, what you just saw is my DNS workflow, right? I like to filter on DNS. I like to come over here to my DNS time. I make sure that I'm on my DNS profile and I just sort DNS time. Why? I'm looking for the slow ones, or I'm looking for patterns. Now let me just jump to the bottom. I'm gonna come up here to the slowest, right? I just sorted on time. If I come up here to my green arrows here, this is where I can go from left to right. I can go to the previous packet, go to the next packet. I can jump to a specific packet. So if I told you, hey, everybody, jump to packet 100,000, you can select that and you can jump to that specific packet. This arrow pointing to that line, that jumps me to the top of my list, and the arrow down is to the bottom of my list. Well, I just sorted this, so let's go ahead and go to the bottom of the list. Now, this is where I can see all my response times. Worst is at the bottom. So right away, I can see that I have one response time that was 750 milliseconds. Right before that, I mean, this wasn't completely isolated either. 729 milliseconds right before this. I saw half a second. I see 480 milliseconds. And you notice here that 750 milliseconds, let's come over here and look at delta time. All right, so now that the delta time between packets displayed, this now looks different than this, right? That's why it's nice to have a dedicated column just for DNS.time in our DNS profile. Now, there's going to be a few more questions that naturally come up. Okay, I saw a couple slow DNS responses. What was the query? What were we looking for? And what was the response? Wouldn't that be natural questions that you would have as well? Well, let's take a look at how we can further add information to our DNS profile. All right, so first of all, I'm going to stay down here, something that I'm interested in. And you know what I'm going to do? Tell you what I'll do. Let's go ahead and right-click this guy. And I'm going to come down here to Conversation Filter. And I'm going to come over here to UDP. DNS, in many cases, in most cases, is running over UDP, except unless we have DNS over TCP enabled. But typically it's a UDP thing. That means connectionless, best effort, send out requests, get response, we hope, in a reasonable amount of time. Overall, from a client side, it's pretty simple. There's quite a bit that happens on the server, on the back end, as it does different lookups. It's looking for top-level domain server, authoritative lookups, and so on. But from the client side, it can be pretty just a one packet request, one packet response type of transaction. I'm going to go to UDP, just filter there, and what I should see, exactly like we see here, I see the request, and then I see the response come back. Now, what do I want, or what am I digging for here? Well, I want to see what the kind of query was, right? What is it that we were interested in looking up? And here I can see our actual DNS name. Now, that's such good information to know about all my queries, and especially if I'm doing some packet digging with DNS. In fact, what I'm going to do is I'm going to select that top packet, and you can follow along with me here. When I do my queries, what I want to do is come down to my DNS stuff. I'm going to go ahead and open this up, and I'm going to come down here to name. I'm going to right click that name. Now you notice at the bottom, dns.query.name. Notice that? I'm going to right click this, and I want to apply that guy as a column. So this will show me what is the name that I'm looking for. Okay, and usually that should be the same in my request and my response. And one more thing that I'm interested in, I'm going to come down here to my response, and I'd like to also throw the answer up there. So in my response is where my answers are, right? So not just my queries. So for this query, come down to answers, and I can see right down here, I want to throw the address up as a column. So now check out our our profile. This is nice, especially when you have a lot of real estate on a machine and you're looking at DNS. This is where I can see I got my name, I've got the actual response. Okay, so what address was returned? I can see my DNS time. I can filter on that. I can sort on that. I could sort on name. How many times do I do a lookup to this exact name? All of this is available within the guts of the protocol itself, but this gives you just one place to look up on our summary view as you're doing your troubleshooting. Okay, so now again, adding things to our profile. One other thing that I do like to do with DNS while I'm on the profiles is we can also go to view and start to add some coloring rules. So what we could do is we could add a coloring rule that makes DNS maybe bright yellow. So I just brought up coloring rules. I'm just going to demonstrate this for you really quickly. I'm going to just say this coloring rule will be, how about DNS normal? And my filter is going to be DNS. All right, so that coloring rule, going to come down here to background. And just for grins, I'm going to come over here. Let's just paint them light blue. I just picked a color, okay? Hit OK, and I'm just going to drag this down just a little bit. Oop, let's go ahead and enable this coloring rule. Come down. There we go. Hit OK. And so you know now, looks like I might have to do another pass on this. Reload. There we go. So now we can see our DNS is just a little bit darker. Now in my coloring rules, this is where I can start to add things like if I see DNS errors, like in my DNS response up here, if I come here to flags, we can see this one is no error. But there's also several errors that it could return. Okay, it could say that it's one is an error code 3, which means that the name doesn't exist. Or there's a whole list, and I'm actually going to show you. I'll actually bring this in. I like to use my little cheat sheet. One moment. I'm doing my DNS analysis. Got a little. There we go. So here's just a quick little list of different DNS codes that I'll look for. So domain name doesn't not exist. Response code 3. Query format error. Response code 1. Name not in zone. Response 9. So those might be things that I'm interested in, and I can add those, and I can create coloring rules for each one of those types of error codes. And all I got to do, I select the error code, and I can right-click that and just say prepare a filter, selected. And what that does is it says, give me all of dns.flags.r code equals 0, 1, 2, 3, 4, 5. So for example, 3, this would be a name doesn't exist, right? Show me in this DNS or in this trace file, all DNS responses with the name didn't exist. Okay, or if we had a server error, or whatever types of DNS errors we could be looking for. Now what I can do is I can create a filter button and even a coloring code for all of those different types of errors, so they really jump out at me. That's my goal with Wireshark. It's super easy to get lost in the weeds, really easy to get lost in the packets. So how can I make this easier to spotlight for myself when I'm digging through the problem? Now to show you, let's just say that I'm interested in looking for name doesn't exist, that type of error, which I have right here, dns.flags.r code. Well, this is where I don't want to ever have to remember the syntax for that again. All right, I mean, when's the last time you typed in dns.flags.r code equals 3 into Wireshark? Maybe yesterday, maybe never. Well, for me, that's not something that I want to have to remember every single time I'm digging for a DNS error. So what I'd like to do is I'm just going to come over here to the top right, hit my little plus button, and what that does is it adds a display filter button for me. So now I can say name, yeah, that thing don't exist. So now I have, for that type of error, instead of needing to remember that, I'm just going to pull this filter. Now, instead of needing to remember that, I can just come up here. Let me just check for that type of error. Nope, no packets met that filter. I'm clean. I don't have that type of issue in this trace file.
Hey, Chris.
Yes, sir.
Can you do our audience a favor? I think some folks want to do a screenshot of those DNS error codes. Could you pull that
Oh,
up just
yeah,
for a second?
I sure could.
So get ready with your screen capture and just go grab that.
Take a picture.
Take a picture. Hey, while we're at it, I might as well do it myself, eh?
Am I in there too?
No, I'm not taking.
Oh man. Okay. Good. And I can
Right, there
also
you go.
send a link to where, I mean, if you just do a Google return message list, I'm sure you'll find a bunch of these out there, but that's just a quick little highlight. Thanks, Dan, for stopping me.
You bet, no worries. Carry on.
Oh, and then Wireshark closed. Okay, last thing I'd like to show the fine people. Boom. Okay, back to my trace file, right? 6,603 packets. Usually, when I'm looking at DNS health, I'm interested in slow or broken, right? Is one of those. If it's not an error, then just show me the slow ones. Well, this is an example of an error over here. Okay, so my DNS.flags are code. But another thing that I would like to see is time, but quickly filter for the slow ones. So again, remember on that column, DNS.time? So that this is a column that we had set up. Well, I can also configure DNS.time as a filter. So let me show you how to do that with Wireshark. I'm going to come up here to our display filter, and I'm interested in DNS.time. Okay, now if I just hit enter, what Wireshark's going to do is it's going to show me all packets in this trace file that have that value true. Is it there or is it not? So usually when I see DNS.time, all it's going to show me is all of my DNS responses in my trace file. Okay, nice, but better would be show me the slow ones. Now, this is where I have to give it a parameter. Now I could say equals .1. That says DNS.time, show me all of the DNS.times that are equal to 100 milliseconds, right? And I don't believe I have any here. So yeah, that's like, it's a very specific number that I gave it. But better would be, show me all DNS.times that are greater than half a second. What do you think about that? So if I ever see DNS slower than half a second, show me those responses. And now I see I've got 3 of them. Now, why did I pick half a second? Well, this is where in Dan Land and Jim Land and Dave Land and all the wonderful people that are here on this webinar with us, you have to figure out what normal is for your environment. You got to do some analysis, take a look, okay, and on any standard Wednesday, what kind of DNS response time should I expect to see? Now, usually if I'm in a local environment, app's not far from me, I'm not going too far into some environment way out in some far off place, well, usually DNS should be pretty, I would say sub 100 milliseconds should be pretty normal. It should be pretty quick. Because again, remember that the client cannot proceed until it gets this answer, until it gets an actual address back. It can't proceed with the TCP connection. So my app is only going to be as fast as my DNS is. If my DNS is slow, the app is going to look slow, when in fact it was just DNS. So for me, I usually, just to give you a little tip, I usually like to put this at .2. Why? Because this shows me any of my DNS responses that are slower than 200 milliseconds. If I'm slower than 200 milliseconds, let's do some basic math. How many DNS turns does it take to add up to 1 second? Well, 200 milliseconds times 5, right? So if I have a client that it does 5 of them, hopefully not in sequence, because now that would be a collective 1 full second of delay. But that's not a whole lot of DNS turns to add up to a full second. You see, humans, we get impatient around between 1 and 3 seconds. When things hit 3 seconds, we're like, ugh, how slow is this thing right here? I'm out, right? Abandonment. It's even worse at 5 seconds, 10 seconds. In a good way, we've learned impatience because things are getting faster. But anymore, if we start to get with that 3 second pain threshold, that's where you're going to start seeing people complain, and that's where your phone's going to start blowing up. So what adds up to that? Well, a lot of times applications, especially web browsers, are not just a single DNS call. In fact, interesting, if you pull up NFL.com, ESPN, even Amazon, look at how many DNS requests you do just to populate that one page, because you're pulling in a lot of different things. Well, if you add delay to every single one of those, that's going to be a combined delay, right? So again, just for me in Chris land, I like to see DNS time that is greater than 0.2. And that, again, that's 200 milliseconds. I don't ever want to have to remember this again. I don't want to have to write this out as a syntax that I have to then memorize. I want to just come over here to plus, and I'm going to come down here to label, and I'm going to say slow DNS. I can put a comment on that filter button as well, and I can say, show me all DNS responses slower than 200 milliseconds. Okay, slow me, don't slow me, show me. One letter makes a big change. Okay, so slow DNS, .2, doing good. I'm gonna say okay. So now I've got that as a button. I can hover over it. I can see a description for it. I see the actual filter context that's there. I can just, now when I go into my trace file, I'm just gonna pull this off. Dan, he was out there, he did an awesome job capturing all these packets, but boy, I gotta get to the slow ones. Let me come to slow DNS. Okay, now I can start to see some of the pain. I can start to see what users are experiencing out there. Now that I see the slow, I don't see necessarily any errors, and I'm just going to take another minute here before we open up to questions. I don't see a whole lot of errors here, but I can see that I have several queries that are going over 200 milliseconds. Well, what do I see in common about those requests? Well, if I come over here, especially with the slowest one, if I just expand this out, name, I see .jp, Japan. We're crossing an ocean to go talk to a system out there. Now, it could be, now this is DNS, right? So I'm looking at my local DNS environment. To resolve this name, it needs to cross an ocean. I could start thinking about a couple things here. First of all, do I expect to see this? Is this something that I would expect that user to be doing in the first place? Maybe I have an application that's distributed around the world and they're going to the wrong regional environment. Maybe they had a little cookie that was stuck in their browser saying, hey, send me the Japanese page. Possible, but that'd be a question that I have. Another question I have, is this something that they frequently should be doing? Because if they do, then I want to take a look at my DNS caching. Is there a reason why we're not caching this query? How long is it caching it for? Maybe I can look at that server. Maybe it's dumping these responses after a few seconds rather than holding on to them for a period of time, so that I don't have to keep doing these same DNS lookups and experiencing that 729 millisecond delay. So those are a few questions that I would start to think about. Now, in this case, maybe I work with Dan and Dan goes, whoa, 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 whoa. Yes, we do have our team in Japan with that. That's absolutely a part of our application, but in San Francisco is our other team, and this person is physically located in San Francisco. So now we can start looking into why are we being directed over to the wrong environment, the wrong page. So again, what did we learn? Let me just do a quick little review on what we learned about our analysis today. So first of all, Dan was able to do his part of the capture remotely. He was able to go in, grab some packets, take a look at an application that was running slow. He was able to send that trace file up to LinkLive, and then he could just give me a call, say, hey, it's out there, why don't you go pull it down, and we can do some collaborative troubleshooting. I pull it down, I'm taking a look at it. In order for an application to operate smoothly, one critical service that's necessary is DNS. We gotta have DNS operating well. We wanna make sure that it's healthy. Now, to help me to do that within Wireshark, I wanna create a DNS profile. Now, what is a profile? It's a set of settings that makes analysis easier for us within Wireshark. So now things that we have, like our delta time column, we have our DNS.time column, we have our name, we have our address response, we have features, coloring rule. We learned how to set some of the filter buttons up here. So now all I got to do is come into my DNS profile and I can start to say, hey, what errors do I have? And do I have any slow responses? That can start to direct my troubleshooting to take a look at the health of DNS. Dan, did I hear you come on for a question?
Sorry, I was clearing my throat because I was going to. Um,
Yeah.
yes, actually, here's a couple of good questions have come in here. But I don't want to interrupt your summary, so feel free to finish off if you want to do that first. Sorry.
Not a problem. I was just wrapping up to the end. So again, what my goal here was to help simplify the workflow for beginning to look at a slow application, and DNS is very critical, right? So sorting on time, right? We can start on our time column, take a look at our slower responses. Now I have some questions. Is this normal? Do I expect to see this? Are we going to the wrong place in the world? Or do we need to look at our DNS server and take a look at its caching? Maybe I have some issues there to make this entire thing from start to finish go more efficiently. Dan, I'll pause and let's take a question.
Sure. Yeah. Great question. If a DNS server blocks a malicious website, what error code would be returned? What would that look like?
Ooh, good question. I don't have an example of that, and I could expect to see a response of a name error. So I might come down here and have it say, it really, I mean, the direct answer is it depends on the configuration. Depends on how that DNS server is configured. But what I would do is I would come down here. It might return maybe a proxy that's safe to go to. It might return a server error like no name. But boy, there's just so many dependencies with that. I can't give you an absolute response. What I can do is try to look at to generate a few of them, and then we can see what we would find there.
Tell you what, why don't we take a look for session number 2? We'll do a little
Okay.
follow-up and see if we can come up with something for that one.
Yeah, sure.
Another kind of question came in from the same person. You know, this could be a method to benchmark different DNS servers, or how would you create a method to benchmark different DNS servers?
Great question. So one thing that I like to do, and something I didn't do here in this one, another thing that I like to add is if I just take one of the queries, or I'm sorry, not the query, but the response. Something else I like to keep my eye on, and it's been very useful, is my time to live. So if I take a look at the IP header, come down to TTL, I'm going to just add this guy as a column as well. And here's the reason, is that time to live is over here. So here's my column. I'm just going to pull this column over maybe towards length. And you know what? For now, protocol, I'm just going to take this guy and I'm going to uncheck it. Why? Well, because it says DNS and I'm on my DNS profile. So that's just real estate that I can save. But time to live. So the question was about how do I benchmark different DNS servers and get a feel for how they're responding. So time to live is nice because this shows me how far away that server is. How does it do that? Well, TTL is a decrementing value by hop, right? We might be familiar with TTL when we're doing a ping, for example. I ping some device, it responds with a response time and a TTL. Well, it's likely that this started at 64, okay, or whatever device is in fact responding. Perhaps I'm doing DNS proxy, but whatever device is actually responding is only 3 hops away. So now that gives me a bit of a context, right? So now I know I'm not crossing the ocean to this physical server. If this was down at 50, then okay, I probably started at 64. I'm 14 hops away from this device. Down at 50, now, okay, 14 hops away, I'm crossing an ocean just to do DNS. That's something I'd want to keep my eye looking for. Now, if you want a replay of what I just talked about with TTL, go check out my YouTube channel. My YouTube channel has all these kind of little tips and tricks, and you know, this can be, that's a concept that I definitely cover in there. But that's something that I would look to do. And then what I want to see is my response time. It's nice to have those next to each other because then I can start to get an idea of what normal is for this server. And then if this ever jumps, then I know I'm going to a different place, or maybe I'm talking to a server that's farther away than I should be, right? That's happened where I'm speaking out to some DNS server in some other environment, or maybe within my ISP and not actually using my local one. So that's something that's helpful. It gives us a context of how far away that server physically is. Hopefully it answers that one, Dan.
Cool. If you don't mind, Chris, I'm going to jump in and share something.
Certainly.
Because kind of along the lines of uh, doing benchmarking, just wanted to show a real quick way to do benchmarking utilizing EtherScope.
Yeah, sure.
So let me,
And while you're doing that, I'm going to build one little graph thing too.
okay. So here on EtherScope, we're looking at what's called our auto test. The auto test capability is kind of a pre-programmed methodology for running multiple tests at once. So for example, here, I'm going to drill in here on this VLAN 20 portion of the auto test. And one aspect of this is that we can designate a particular DNS server for the test to run the DNS lookup time test. So here we see that the DNS.google.com responded in 16 milliseconds. So that can always be part of your auto test. And in addition, then we can also run some sort of an HTTP test. So I can create, put in a URL here that could be querying an application in my network. And doing the DNS lookup for that URL will always be part of that HTTP test. And we'll also see TCP connect time, the data start time, data transfer time, and chart that out here in a handy little profile chart. So whenever you run an auto test, your standard DNS servers can be tested, and critical applications and or anything that you can throw into a URL can be part of this test. You can also add into the configuration of this test an expected response. So, if going to this URL should generate a specific response code or text code, that can also be tested to see if that response comes back through. So I just wanted to make sure and share the fact that you don't necessarily have to go to Wireshark to be able to see what's going on with DNS. With that, Chris, I'm going to switch back over to you.
Thank you, sir. Thanks for showing us that.
And there it goes.
And we back into Wireshark. You can see me okay? All right, hopefully you can see my screen. I just shared Wireshark. Dan, maybe you can just jump in case you don't.
Maybe it's just me. I'm not looking in the right spot. So.
All right. I did create an IO graph for my DNS profile, and you can get to this under the statistics menu. And that's where you come into IO graphs. And what I can do is I can create a line that graphs DNS response time over time that are in my trace. So all I have to do is just create I just said my graph name, my display filter is DNS.time. So any packet with that value will be displayed. It's a line graph. And what I did is I said on the x-axis, just give them the maximum value of that field within my interval. My interval is 1 second. So every second, the maximum DNS time is going to be graphed out for me. So what this does, it shows me, okay, I can see at one point I did get a pretty high one. I think that was the 720-second one. But this shows me over time back to like benchmarking. What is my overall response time, and does it ever really peak? And does it go back to normal? But I can tell that right from a trace. So again, here's some tips and tricks with Wireshark. I hope you found this part of the webinar useful, getting a bit more out of some of the features within Wireshark. I have a lot to say on this, which is why we have a Wireshark full training class, right? This is a 2-day full virtual training class delivered over Zoom. Going to make sure that you have the link to that down in the chat, and go ahead and go out to my website and check that out, or stay close to what I'm up to out on YouTube, because there's a ton of depth we could go to with Wireshark, but hopefully this was a useful 40 minutes of tips and tricks to share. So I'm going to share that link to you, and you can go get some more information about that for more Wireshark. Back to you, Dan.
And that takes us to the top of the hour. Chris, there's a couple of questions that we're not going to have time to get to, but I think what we'll do is you and I can converse about those offline, and we can get those answers back out to the folks who've asked. So
Sure
with
can.
that, great, fantastic content, Chris, and I really like the way that you present. Clearly, you do this a lot, and you know what people need to hear in order to understand. So fantastic job. We really appreciate it.
Great to be here, Dan. Thanks for having me.
And we will see you next week at part 2. Thanks, everybody. This concludes today's webcast.